Hey everyone, welcome back to the College Algebra playlist. In this video, we'll be taking a look at polynomials and adding like terms. So let's dive in. First off, we want to define what a polynomial is. It's a special type of algebraic expression. Namely, it's an expression in this form right here. Okay? This looks pretty confusing and messy right now, so let's break it down piece by piece and uncover what's really going on with polynomials. Okay, first off, we want to say that the constants a sub n all the way down to a sub 2 and a sub 1 and a sub 0 can be any real number. Okay, so those are just numbers. Also, the exponents on the variable x, the exponents n through n minus 1 through n minus 2 all the way down to 3, 2, 1, 0, those exponents must be whole numbers. Okay, in order for this algebraic expression to be a polynomial, the exponents have to be whole numbers. Okay? So let's break down a few more definitions here. Each real number, ai, where I runs from n all the way down to 3, then 2, then 1, is called a coefficient. Okay, so each number in blue here is a coefficient. All right. The number a sub 0 is a constant. Okay, so this is just some number that's tacked on to the end here. Each product, a sub I times x to the I, is called a term of the polynomial. Okay, so these things in green here are all terms. All right. We need to differentiate between terms and factors. All right, terms are things that are being added together, and factors are things that are being multiplied together. All right, so it's important to know that difference. Moving on, the highest power of the variable that occurs in the polynomial is called the degree of the polynomial. All right, so this is a degree n polynomial in its general form. The leading term is the term with the highest power, so that's a sub n times x to the n. And its coefficient is called the leading coefficient. Okay, so that's a sub n. All right, let's look at some examples of polynomials. Okay, here I have 3x squared plus 5x minus 7. This is a polynomial of degree 2 with a leading term 3x squared, and it has a leading coefficient of 3. Okay, so this is a pretty simple example. Next, we have 6x to the 4th minus 4x squared plus 8x plus 3. This degree is 4. The leading term is 6x to the 4, and the leading coefficient is 6. And even something as simple as this, 7x plus 1, this qualifies as a polynomial. It's a degree 1. Okay, one of my previous teachers used to say that algebra is about seeing what's not there, right? There's an invisible power 1 right here being applied to the x. So we need to see this as a degree 1. Okay, anything raised to the 1 power is just equal to itself. Okay, so x to the 1 is just x. That's what we have. And this leading term is 7x, and the leading coefficient is 7. So that's our example. Now let's look at some non-examples of polynomials. Here I have x to the negative 2 plus 3x plus 1. Why is this not a polynomial? It's because exponents can't be negative. Okay, we can't have this negative 2 business here. The exponents have to be whole numbers, 0, 1, 2, 3, 4, on and on to infinity. Here we have the square root of x plus 2. And this is not a polynomial because of this square root going on, right? If you'll recall from the radicals and rational exponents video, you'll remember me saying that radicals and rational exponents are interchangeable. Okay, so the square root of x is the same thing as x to the 1/2 power. All right, and exponents can't be fractions in polynomials. Here we have 1 over x plus 4. Exponents can't be negative. Okay, this 1 over x is the same thing as x to the negative 1 power. X to the negative 1 power. All right, so these non-examples are not polynomials. All right. Next, let's talk about certain types of polynomials, okay? If it only has one term, right, if there's only one term like 5x cubed, that's called a monomial, all right? If it has two terms, like 6x plus 4, that's called a binomial, okay? And if there are three terms, like 3x squared plus 4x minus 5, that's called a trinomial. In our upcoming problems, we're going to be asked to add and subtract polynomials, okay? So this is not an easy task. It takes a lot of time. It takes several steps. So before we try to add and subtract polynomials, we need to take a look at like terms, okay? Adding like terms is something we need to learn. All right, first let's define what like terms are. Algebraic terms that contain the exact same variables raised to the same power are called like terms. So let's look at some examples. 5x and 3x are like terms because they have the same variable x. All right, 4y squared and 6y squared are like terms because they have the same variable y, and they're being raised to the same power 2. Okay, for some non-examples, 2x and 7y are not like terms. Okay, they don't involve the same variable. Okay, we have two different variables going on here, x and y. All right, and lastly, 8x squared and 9x cubed are not like terms because they have different powers. All right, they have the same variable x, but this has a power 2 and this has a power 3, so they're not like terms. Next, let's actually try to add like terms. All right, 5x plus 3x, what does that equal to? Well, if your intuition is good, you can tell that 5x plus 3x is equal to 8x. Okay, that's my answer. But the question is why? Why is that true? I want to try to break down what's happening exactly when you add like terms. I wish someone had showed me this when I was first learning it, because I thought that adding like terms was really confusing. I didn't really know what was happening until I saw the following breakdown. All right, this is going to get a little confusing and messy. All right, so fasten your seatbelts. But I'd like to show you exactly what's happening when we add like terms. Okay? The distributive property tells us that if we have a times b plus c, we multiply the a by the b, and we multiply the a by the c, and we add the results. Okay? So a times b plus c equals ab plus ac. All right, this is a property we know. We've seen this before. But now the question is, what happens when I swap the order of the multiplication here? Okay, a times b plus c, I'm swapping that to b plus c times a. Well, remember the commutative property of multiplication says it doesn't matter what order we multiply in, we'll get the same thing. Okay, so on the right-hand side, I should have ab plus ac still. All right? But I want to look at this in a different way. Here, we see that the b is being multiplied by the a, and the c is being multiplied by the a, and we're adding the results. Okay, reading this from left to right like it's a sentence in English. I have b plus c times a equals ba plus ca. Okay, so AB is the same thing as BA by the commutative property, and AC is the same as CA, also by the commutative property. Okay, so this is what I have. I almost have the desired result. All right, I just want to apply this to a concrete example. Okay, say I have 5 plus 3 times x. All right, this new version of the distributive property that we derived, this new version says take the 5 and multiply it by the x, and take the 3 and multiply it by the x, and add the results. Okay? So what I have here by the distributive property is going to help me add like terms. All right? So let me go back one step. The next thing I want to do is swap the left and right hand sides. Okay, I can do that. There's nothing that says I can't do that. The equality still holds. Okay, so I have 5x plus 3x equals 5 plus 3 times x. All right, 5x plus 3x is exactly what I have up here in black. All right, so let's switch back to black. Here we have 5x plus 3x equals 5 plus 3 times x. In parentheses, that 5 plus 3 just becomes 8. So our answer is 8x. So congrats, we've just added like terms for the first time, and we took a look at why it works. All right, here are some examples. 4y plus 8y, we're just going to add the coefficients, right? 4 plus 8 is 12, so we get 12y. 5x minus 8x, here we add the coefficients again, right? But we're adding by a negative number, so that's subtraction. Right? We have 5 minus 8 in parentheses, and 5 minus 8 is negative 3. So our answer is negative 3x. Here, once again, we add the coefficients. We add 6 plus 4, and we get 10. So the answer is 10w squared. Okay, now that we've seen how to add like terms, we're ready to add polynomials. All right, so let's get started. The first thing we want to do is get rid of the parentheses. Okay, the parentheses aren't necessary here. We have to be careful when we do that, but because there's an addition happening here, we can just get rid of them. Okay, so the parentheses are gone now, and we take a look at this term right here, 4x cubed. Looks like my highest power that occurs is 3, so I'm going to take this to the front. Okay, traditionally we report it from left to right with the highest exponent first. Okay, and then we'll move down to 2 and 1 and 0. Okay, so the next thing I want to do is point out that there are some like terms here, right? There's 12x squared and 8x squared in red. Okay, so we're going to add those together. All right, that's what I have in red there. Next, I see that 9x and negative 5x are like terms. So we're going to add those together in green here. And then I just have some constants floating around, right? I have negative 21 and 20 in orange here. So we're going to add those together as well. All right, the next step, we just want to clean up the business in parentheses, right? 12x squared plus 8x squared is 20x squared, okay? 9x minus 5x is 4x, and negative 21 plus 20 is negative 1. So for the next step, we just get rid of the parentheses, right? Adding by a negative number is subtraction, okay? So this is my final answer. All right. Next, let's take a look at subtracting polynomials. All right, this is a little harder, but we can handle it, no problem. All right, so the first step is to get rid of the parentheses. So I'm just going to take them off like that. And I've made a mistake here. All right, pause the video and take a moment and ask yourself, what's the mistake? Okay, why is this incorrect? It's incorrect because of this minus sign right here, okay? I have to distribute this minus sign to each piece of the trinomial. All right, I'm subtracting the entire trinomial. All right, so let's go back to the beginning and let's try this again. Okay, this minus sign here, I actually want to look at this in a different way. Okay, when I subtract an entire trinomial, that is the same thing as distributing a negative 1 to each piece of the trinomial, okay? Negative 1 times this whole thing, that's the same thing as subtracting. All right, so I'm actually going to apply this negative 1 to each piece of the trinomial, right? I'm going to use the distributive property to get rid of the parentheses. Okay, so I have plus negative 6x squared plus negative 5x plus negative 15. All right. Cleaning this up just a little bit, I'm just turning these negative numbers into subtraction. All right. Let's bring this result to the top of the screen, okay? Because we still need to add like terms. All right, let's do that right now. So the 6x cubed, that's already out in front for us. That's good. Okay, that's the highest power. All right, so this is a degree 3 polynomial. Okay. I have some like terms here in blue. Okay, so let's add those together. Next I have like terms in red. Okay, so let's add those together. And lastly, I just have these constants in green here. So let's add those together. Cleaning up the stuff in parentheses, we have negative 4x squared minus 6x squared. That equals negative 10x squared. And then 3x minus 5x, that equals negative 2x. And then negative 5 minus 15, that equals negative 20. Okay? So now we get rid of the parentheses. And this is our final answer. All right, so that does it for this video. In the next video, we're going to take a look at multiplication. Okay, what happens when you try to multiply polynomials together? All right, thank you for watching, and like and subscribe.